It's Wednesday, and today we're talking about data distributions and the effect of outliers. I'm going to be showing you the three shapes for distributions, and then we'll be talking about how to actually calculate outliers and how outliers affect mean, median, mode, range, all that jazz. All right, so the first shape here is symmetric, and symmetric just in real life means the same on both sides. So this normal curve, this bell curve, whatever, is going to be the same on both sides. I left all the words for you to read on your own. I'm just going to do the short definitions of it. Okay, but if you do have a symmetric curve, it actually will have the mean, median, and mode. They'll be the same or close to the same. Obviously, you don't often get a perfect bell curve, but close enough. Its average or its mean is in the middle because these low values and high values sort of cancel each other out, and then average is in the middle. Obviously, median, if I count halfway up, halfway down, the median will be there. And the mode, obviously, you can see there's more of these data points. So for the most part, whether it's perfectly symmetric or not, those values will all be pretty close to that middle value there, which is really cool. All right, then the next two are skewed left and skewed right. And this is more like how data really is, especially with outliers, which we're talking about today. Okay, so skewed right means that it's going to have a tail that goes to the right. And this is kind of like salaries in America. So we got all these American people who are making like $50,000 a year and maybe $100,000 a year. And so then, you know, the average American earns, I don't know, $70,000 a year. But as soon as you throw in somebody like Bill Gates who earns billions of dollars a year, I mean, I assume he makes billions, he's a billionaire, that's going to pull that average up. So the mean typically gets pulled towards the tail. So this is all of the Americans are down here making whatever normal amount of money. And then you include millionaires and billionaires, they're going to pull the average American salary higher. There aren't very many of those people. The vast majority of people are normal people that make $50,000, $100,000, whatever a year, and there's only a few Bill Gates and Oprah Winfrey's in the world. So there's only a small number there. So it's going to pull that average higher, but the median is still going to be somewhere in this big cluster because the vast majority of people are still going to fall in this group, but there's only going to be a couple people up here. So the median's generally somewhere in this big cluster, and then the average will be pulled higher. So the mean and median are no longer together when it's skewed right. Same exact thing for skewed left. And I see this all the time. I'll be giving a test and people will make an 89 and 95 and things like that. And then there's that one kid who didn't study or literally wrote their name on it and didn't do anything else, and they make a 0 or a 10 or whatever. And then you guys ask the class average, and I say, well, the average is a 70, but that doesn't reflect properly the actual grades. This 10% pulled the average down. So the vast majority of students scored in the 80-90 range, but then one or two kids did poorly, and that pulls the average down towards those kids. Again, the median, which is why I like to tell the median score, the median gives a pretty good reflection. Half the kids scored above this and half scored below. So the median is going to be kind of in that big cluster area, but then the average, if you account for everybody, especially if there's an outlier, if there's somebody that, you know, got a 0, which I've had happen before, that's going to pull the average down further. So down here, I'm just asking the shape. So shape, if I have a tail going towards the left, then it's going to be skewed left. This one, the vast majority of the data points are here, but I have a couple here, so it kind of has this shape to the right. I'm going to skip the word skewed and just say skewed to the right. This one actually is pretty perfect, but they don't have to be exactly perfect, but I do see 25% of the data is in this section, 25 there, 25, 25. It's pretty symmetric. So those are pretty easy questions looking at pictures. All right, so let's go ahead and talk about how to actually identify an outlier and then what it actually does when you include it or exclude it from a data set. So there's actually specifically two definitions because you can have a lower outlier and an upper outlier. So what you're going to do is you're going to find the inner quartile range. So remember that's Q3 minus Q1. You're going to multiply 1.5 times that value. And then if you're trying to find a lower outlier, you're going to look for that lower quartile minus that value. If you're trying to do an upper quartile, you do that quartile 3 plus that value. Okay, so what that means is I'm going to find my inner quartile range. So this is between Q1 and Q3. And I'm going to, from Q3, I'm going to add a certain value and find some cutoff point. And if I have a number that is beyond that point, it is an outlier. If it's within that value, whatever I find out, it is not an outlier. Okay, so to find an upper outlier, I'm going to use Q3 times that 1.5 IQR stuff. Okay, then to find a lower outlier, I'm going to take Q1, I'm going to subtract that 1.5 times the IQR, find some cutoff value, and then if anything is below that value, it's an outlier. If it's equal to or not below that outlier value, then it's not going to be an outlier. Okay, so I gave you one where I actually give you the values and one where I make you work for it. So let's just go ahead and do the one where I give you the values first. It's a little out of order, but we'll just do it. Okay, so the stem and leaf plot shows the number of items and 12 collections in a museum. Does the data have an outlier? Okay, so looking at it, likely, and again, don't forget that 2 line 6 means 26. So this really means 3 items, 5 items, 7, whatever. It's not likely that 3 is an outlier because there's another 3. Normally outliers aren't repeated. So likely it's only this 39 if it exists as an outlier. So we're going to go ahead and calculate the upper outlier for this guy. So you're going to multiply 1.5 times the IQR. Well, the IQR is 13 minus 6. I'll go ahead and write that down just so you can see it. Okay, so 1.5 times 7. Let me pause. I don't have a calculator. And I'm back. All right, so 1.5 times 7 is 10.5. Okay, so I'm going to take, because I'm going to try to find an upper outlier, I'm going to take Q3 and add it. So Q3 is 13, so I'm going to say 13 plus, and then that's 10.5. So my number is 23.5. That's my cutoff value. So anything higher, greater than, not equal to, so if I had a 23.5, then that's not an outlier, but it has to be greater than 23.5. Well, 23.5 is actually less than this 26. So 26 and 39 actually are both outliers. You normally wouldn't expect, I mean, I would have guessed 39 is an outlier, but I would not have guessed 26 is an outlier. But both those guys fall outside of that 1.5 times the IQR, and I added up. So outliers, yes. I'm just going to say yes, and I'm going to say 26 and 39. Okay, I don't want to check for a lower outlier. I'll just do it on another problem, but I would do this 10.5. I'll just do it aloud. 10.5, and I would say 6 minus 10.5. That's negative something something. So then 0.3, whatever, is not less than negative something. So 3 is not an outlier. All right, so let's go ahead and do number 4. I'm just going to do it on my calculator. It's the exact same directions on the emulator, so just do it on the calculator however you need to. But I'm going to type in all of these data points. So I'm going to go to Stat, I'm going to go to Edit, and I'm going to type in all those points real quick. So I'm going to pause. All right, so I typed all those in, going to 150. If I were just to guess, I would say, yeah, 150 is probably an outlier. But we've just seen that, I mean, who knows? Sometimes data is weird. So this 60 could be an outlier. I have no idea. So type your data points in. I need to find Q1 and Q3. That's really the whole point. So I'm going to go to Stat, I'm going to go to Calc, I'm going to go to 1var stats, press enter, 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 and scroll down. All I literally need is Q3 and Q1. So Q3 is 47.5 and Q1 is 35. So I'm going to go ahead and calculate my interquartile range. 47.5 minus 35 is 12.5. Don't need a calculator for that. Okay, and I want to go ahead and figure out my upper outlier. So Q3 is 47.5, and I'm going to add 1.5 times that interquartile range. So I will go ahead and type that in the calculator. So, and I'll just type it all in together. 47.5 plus 1.5 times 12.5. So my cutoff range is 66.25. So anything higher than 66.25 is going to be an outlier. Sorry, this recording thing keeps messing up. So anyway, anything higher than 66.25 will be an outlier. So yes, my outlier is 150. If you want to check a lower outlier, my Q1 is 35, so I would say 35 minus 1.5 times that 12.5. Anything lower than 16.25 would be a lower outlier, but obviously my lowest data point is 25, so no other outlier besides 150. All right, so just one more example where we are given a data set and we're going to add an outlier and then see what it affects. But firstly, I just want you to use your brains and just see how things are affected by adding or removing an outlier. So the mean is the easiest thing to change. I could change a number by just changing it from 15 to 15.1 and it would change the mean. The mean will always change, and by a lot. If you're adding an outlier, you're going to be changing that mean by a lot. Like I said, adding Bill Gates or adding a 0 student is going to change that average by a whole bunch. Okay, the median, that's a math term there. It may or may not change. It really just depends on how your data is set up. If you have a whole bunch of points that are repeated in the middle and you add an outlier, it just shifts your data over one thing, but your median is still going to be the same value. So your median could change or it could not change depending on how those values line up, but it's not going to change by a lot. Your mode should not change at all, because if your mode is the most often, adding an outlier shouldn't be the most often point, otherwise it's not an outlier. Standard deviation always changes. He's going to change by a lot. Him and mean are attached to the hip. They will always change together. The range should change by a lot. If you're adding an outlier, you're adding an extreme low value or an extreme high value, you should always change your range. And then also interquartile range is another meh. It just depends on how your data points are set up, whether or not those points are actually going to be shifting up or down. So our last little thing here says she played 4 rounds of golf, these guys here, and then she scored a low 80 here. So what's going to change? I'm going to show you how to do it mathematically, but just use our brains. Is the mean going to change? Why, of course the mean's going to change. The mean always changes. If the mean changes, standard deviation always changes. Those two are guaranteed. Because I added a number, so here's my original 4, because I added a number outside of my data set, automatically my range is going to change, guaranteed. Because I'm now having, instead of a range of 6, I'm going to have a range of more than 6. Okay, the median originally was halfway between these 2 points, but now when I add another point, the median is now the middle of 5 points, so the median is going to change. There is no mode, so the mode's not going to change, and the interquartile range originally, it's going to be, it's weird when there's like half points, but it's going to cut in the middle and be here, or be here, and be here, but I'm now adding another point, so it's going to pull my median down, and my interquartile range will also change. So I already know the answer without doing any math whatsoever. Sorry for that little mess up on that one. But I'm going to go ahead and show you how to do it mathematically. So I'm going to go to Stat, and I'm going to edit my data. And I've already typed in my first 4 data points, the ones that are excluding this outlier. And I'm going to press Stat, go to Calc, go to 1var Stats, press Enter, 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 Enter. And I'm going to write down those points real quick. Okay, so all I did was I ran my stats here, and I just went through and I found my values. Mean 93, standard deviation 2.58, and I just wrote them down. So I just wrote it down without the outlier included. Now I'm going to go back and recalculate with the outlier included. So I'm going to go back to Stat, I'm going to go to Edit, and I already have those 4 data points. I'm just going to throw in that 80. So I just added him to the bottom, make sure it is 80. Yep, it is. I'm going to go to Stat, I'm going to go to Calc, I'm going to go to 1var Stats, press Enter, 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 Enter. And now I'm just going to compare those data points. So, without out of the screen here, 93 turned into 90.4. It pulled the average down. So yes, the median, well, I'll go ahead and do standard deviation. Standard deviation is now 6.23. Sorry about the light there. But it was 2.58, so that changed. Going on down, median is now 92. It originally was 93, so that guy changed. Okay. The mode, obviously it doesn't tell you on here. You just gotta use your brain. Mode didn't change. The range went from 6, and now it's 16. Interquartile range went from 5, and now it's 10. So you could actually write down all these values and just see that they changed. But the take-home message I want you to know, besides how to actually calculate yes or no it's an outlier, is mean and standard deviation always change. Always. The range should change if you're adding an outlier, specifically an outlier. Everything else just depends on how your data is set up, whether it changes or not. But make sure you can actually calculate outliers with that 1.5 IQR plus or minus that Q3 or Q1. All right, your homework will be on Canvas, and there actually is no Delta Math, so you only have a couple problems. All right, see you guys tomorrow.